So we'll discuss about sodium. Sodium does not occur as a free metal in nature because it is too reactive and readily combined with other elements and compounds. It is found in the sea as a sodium chloride, sodium bromide, and sodium iodide. It is also found in deposits as a rock salts. तो सोडियम जो है ये फ्री जो है ना ये फ्री मेटल नहीं पाया जाता क्योंकि ये बहुत ज़्यादा रिएक्टिव होता है और ये बाकी जो एलिमेंट्स हैं उनके साथ ही कंबाइन हो जाता है बाकी जो एलिमेंट्स हैं उनके साथ कंबाइन हो जाते हैं एलिमेंट्स और कंपाउंड जो होते हैं तो यानी ये फ्री स्टेट में नहीं पाया जाता बल्कि ये बाकी एलिमेंट्स या कंपाउंड के साथ कंबाइन हो जाता है। तो ये समंदर में समंदर में पाया जाता है। तो एज ए सोडियम क्लोराइड यानी जो समुद्र का पानी होता है और सोडियम ब्रोमाइड, सोडियम आयोडाइड एंड ये रॉक साल्ट के जो डिपॉजिट उनमें भी पाया जाता है। So this is the sodium metal. You can say this is sodium metal. It's given here, which is cut into pieces. So note when freshly cut, the alkaline metal shows a shiny and silvery surface that rapidly tarnishes in air. जब फ्रेशली यानी अल्कली मेटल्स को हम कट लगाते हैं तो ये फिर क्या करते हैं शाइनी और सिल्वरी जो सरफेस जो इनका होता है वो टार्निशेस है यानी एयर में टार्निश कर जाता है यानी तो ये जो ना number position of sodium in the periodic table. Sodium belongs to alkali metal. Sodium atomic number is 11 and its symbol is Na. It occupies first position in the third period and third position in the group first as it has 3 electronic shells and only 1 electron in the valence shell. तो सोडियम जो है ये अल्कली मेटल्स के साथ बिलोंग करता है। इसका एटॉमिक नंबर है 11 और इसका जो सिंबल है वो सोडियम है। तो ये जो ना फर्स्ट पोजीशन इसका होता है थर्ड पीरियड में, इसका फर्स्ट पोजीशन है और ये इसका थर्ड पोजीशन है ग्रुप 1 में और इसके 3 इलेक्ट्रॉनिक शेल्स होते हैं और हर वैलेंस शेल में 1 इलेक्ट्रॉन होता है। Table 8.4 Physical properties of sodium. Serial number 1, 2, 3, 4, 5. So characteristics and properties. Sodium is, you can say, in appearance silvery, white solid, and in softness, you can say it is soft metal. It can be cut with a knife. Density is 0.971 gram per cubic centimeter. Melting point is 97.60 degrees Celsius. Boiling point is 880 degrees Celsius. Tensile strength has relatively low tensile strength. Lightness, lighter than water. It floats on the surface of water. तो ये मतलब इनकी जो फिजिकल प्रॉपर्टीज है सोडियम की। मेलिएबल, सोडियम मेलिएबल एंड डक्टाइल होता है और कंडक्टिविटी इज गुड कंडक्टर ऑफ हीट एंड इलेक्ट्रिसिटी। Now, chemical properties of sodium. Sodium is very reactive alkali metals. It is a strong reducing agent. Some of simple reactions are given below. तो सोडियम जो है ये बहुत रिएक्टिव अल्कली मेटल है और ये स्ट्रांग रिड्यूसिंग एजेंट है सोडियम। तो इसकी जो केमिकल रिएक्शंस है वो ये रिएक्शंस विद हाइड्रोजन। तो सोडियम को अगर हम हाइड्रोजन के साथ मिला लें तो इसका जो केमिकल रिएक्शन है वो इन द फॉर्म ऑफ सोडियम हाइड्राइड्स। So you can say sodium reacts with hydrogen to form sodium hydrides. So you can say this is sodium which reacts with hydrogen to form sodium hydride. So you can say that reaction oxygen, सोडियम का जो रिएक्शन ऑक्सीजन के साथ किया है, sodium we can say reacts with oxygen to form basic oxides, Na2O, which on reaction with water forms alkali, in which this is a characteristic reaction for metals. That's why the elements in this groups are called alkali metals. So we can say sodium plus oxygen, so you can say Na2, and Na2 reaction with water to produce sodium hydroxide. So you can say that this is reaction of sodium with oxygen to produce Na2, and this Na2 reacts with water to produce NOH. Now, reaction with water. Sodium reacts with water vigorously, liberating hydrogen. The reaction is exothermic because of the heat produced. The liberated hydrogen catches fire. तो पानी के साथ अगर हम हाइड्रोजन को मिलाएंगे तो इसका जो रिएक्शन होगा वो वेगोरस होगा और ये हाइड्रोजन को लिबरेट करेगा और ये हाईली एक्सोथर्मिक रिएक्शन होता है क्योंकि इसमें हीट प्रोड्यूस होता है इस रिएक्शन के दौरान, जिस तरह ये हीट बना हुआ है। और इसके अलावा जो लिबरेटेड हाइड्रोजन है ये कैचेस फायर, ये खतरनाक होता है, ये फायर को कैच करता है, तो इसके अलावा एनर्जी बनता है। तो दैट इज द रिएक्शन ऑफ सोडियम विद वाटर। नाउ due to higher activity of sodium is kept in kerosene oil or liquid paraffin to avoid its contact with air, oxygen and water. सोडियम की चूंकि हाईली रिएक्टिव है तो ड्यू टू हाई रिएक्टिविटी सोडियम को हम केरोसिन ऑयल में रखते हैं या जो लिक्विड पैराफिन है ताकि ये एयर के साथ इनका कंटेक्ट ना हो, यानी एयर या ऑक्सीजन या वाटर के साथ इनका कंटेक्ट ना हो। तो next one is reaction with halogens. Sodium reacts with halogens to form sodium halides, such as sodium reacts with chlorine to produce sodium chloride, and sodium reacts with bromine to produce sodium bromide. Reaction with sulfur. Sodium reacts with sulfur to form sodium sulfide. Reaction as a reducing agent. Sodium is a powerful reducing agent. It reduces most of the oxides and halides. So we can say that sodium reacts with magnesium oxide, sodium oxide with magnesium, and you can say that reaction with halides, tellurium halides, sodium chloride is formed. In this case, we can say uses of sodium. Some of the uses of sodium are as follows. It is used in the preparation of important compounds such as sodium carbonate, sodium bicarbonate, sodium hydroxide, sodamide, NaNH3, and NH2, sodamite, etc. It is used in sodium vapor lamps, which gives a bright orange yellowish light for street lighting. It is used as a covalent nuclear reactor. It is used in the purification of petroleum in order to remove sulfur from it. This process is called desulfurization. It is used as a reducing agent to prepare metals such as titanium, zirconium, etc. from their chlorides and oxides. It forms alloys with other metals, so it is the most useful alloy in which mercury called sodium amalgam and with silver metal. Next one is magnesium. Magnesium is the number of alkaline earth metals. It occurs in nature only in combined state. You can say as a dolomite, CaCO3, and MgCO3. Cassiterite, MgSO4, and Epsom salt, MgSO4, 72. In many silicates, including talc and asbestos, magnesium is present in seawater as chlorides and bromides. It is responsible for permanent hardness of water. It is also an essential constituent of chlorophyll in green plant. Position of magnesium in the periodic table. Magnesium atomic number is 12 and its symbol is Mg. It occupies second position in 3 periods and second position in group 2A. It has 3 electronic shells. And 2 electrons in the valence shell. So this is the physical properties of sodium. I can say that sodium is in appearance silvery gray solid. Its density is 1.74 gram per cubic centimeter. So you can say gram per cubic centimeter. It has a melting point 651 degrees Celsius, boiling point 1106, malleable and ductile, conductivity, good conductor of heat and electricity. Calcium is, now let's come towards calcium. Say calcium. Calcium is too reactive to occur as a free metal in nature. It occurs abundantly in the combined state in minerals such as calcium carbonate, in limestone, marbles, chalk, and as a calcium sulfate in gypsum. So this is a marble and this is a pure calcium. And so position of calcium in periodic table. Calcium atomic number is 20 and its symbol is Ca. It occupies second position in the fourth period and third position in group 2. So it has 4 electronic shells and 2 electrons in the valence shell. Physical properties of calcium. Calcium is silvery white solid in appearance. Its density is 1.55 gram per cubic centimeters. It has 851 degrees Celsius melting point. and 1487 degrees Celsius boiling point. It's malleable, ductile. Its conductivity, good conductor of heat and electricity. Chemical properties of magnesium and calcium. Magnesium and calcium combine directly with hydrogen, forming hydrides. So this is the magnesium reaction with the hydrogen form magnesium hydrides and heating calcium and hydrogen to produce calcium hydrides. So both magnesium and calcium burns in air. Magnesium burns with dazzling of flame, forming magnesium oxide, commonly known as magnesium, while calcium forms calcium oxide. The characteristics brick red color flame. So this is magnesium plus oxygen, magnesium oxide. You can say calcium plus oxygen, calcium oxide, and heating. So we can say when these oxides, magnesium oxides and calcium oxides are dissolved in water, they form basic solutions. Magnesium oxides plus water, so magnesium hydroxide. Calcium oxide plus water, calcium hydroxide. Magnesium and calcium reacts with nitrogen, forming their respective nitrides. Magnesium plus nitrogen to produce magnesium nitrides. Calcium and nitrogen to produce calcium Ca 3 and 2. So magnesium and calcium reacts with acid, liberating hydrogen gas. So magnesium reacts with HCl to produce magnesium chloride and hydrogen gas. So magnesium reacts with sulfuric acid to produce magnesium sulfate and hydrogen gas. And this calcium reacts with HCl to produce calcium chloride and hydrogen. So calcium reacts with sulfuric acid to produce calcium sulfate and hydrogen. Magnesium and calcium reacts with halogen to form their respective halides. Magnesium plus chlorine to produce magnesium chloride, magnesium plus bromine to produce magnesium bromide, calcium plus chlorine to produce calcium chloride, and calcium plus bromine to produce calcium bromide. Now, uses of magnesium and calcium. Uses of magnesium. Some of the uses of magnesium are following. Magnesium is a low density metal, so it is used in formation of light, but tough alloys such as duralumin, a mixture of aluminium, copper, magnesium and manganese, and magnesium, a mixture of aluminium and magnesium. These alloys are used for the construction of aircrafts, cars, and moving parts of the machines. It is also used in photographic flash light powder, flames, and fireworks. It is used as a antioxidant in metallurgy and in the extraction of titanium and uranium. Its compounds such as magnesium oxide are mixed with the clay to make refractive bricks for furnace. Magnesium sulfate is used in textile, paper industry, soap formation, and pharmaceutical industry, etc. Uses of calcium. Now, some of the uses of calcium is following. Calcium is used as a deoxidant in steel casting and copper alloys. It is used in the making of calcium fluorides and calcium hydrides and in the extraction of uranium. There are compounds such as lime, calcium oxide is added to soil as a fertilizer to decrease its acidity. It is also used for water softening, pollution control, and in pulp, paper, sugar, and glass manufacturing industry. It is used in steel making. Soft and hard metals. Elements of group 2 transition metals, lanthanides and actinides are all metals, but there is much difference in the properties of these metals. So we can say the metal present in group first and second are soft, very reactive, having low ionization energies, very electropositive, known as soft metals. Metals like copper, silver, iron are less reactive, having high ionization energy, less electropositive, known as the hard metals or noble metals. Their melting points, boiling points, and densities show much higher values. The comparison of properties of sodium and you can say iron representative is given below. Comparison of properties of sodium and iron. So this is sodium, this is iron. So sodium is an alkali metal with atomic number 11. Iron is a transition metal with atomic number 26. One electron is its outermost shell and is very soft and can be cut with a knife. Hard and require great energy to break. Weak attraction force between atoms of sodium. Strong attractive force between atoms of iron. The melting point of sodium is 97.6 degrees Celsius. The melting point of iron is 1538 degrees Celsius. Boiling point of sodium is 880 degrees centigrade. Boiling point of iron is 2862 degrees Celsius. Low density of sodium 0.9 to 7 gram per cubic centimeter, while that of density of iron is 7.8 to 74 gram per cubic centimeter. Lighter and floats on the surface of the water, heavy and settles at the bottom of the water. Low tensile strength cannot be used where stress is required. High tensile strength and can be used in construction of building and bridges. It is used to prepare steel. Sodium is very reactive, stored in kerosene oil, and the iron is less reactive than sodium. Inertness of noble metals. Group first and second metals are fairly reactive because of their low ionization potential, but the transition metals have a tendency of low reactivity. Their low reactivity is due to their high ionization energy. Noble metals and those metals which resist oxidation and corrosion in moist air, unlike most base metals. Chemical noble metals are ruthenium, rubidium, palladium, silver, osmium, iridium, platinum, and gold. Some chemists include mercury, rhenium, and copper as noble metals. Their minerals are relatively inert and found free in nature. The noble metals are valuable because of their inertness, rarity in the earth crust, and their usefulness in the area like metallurgy, high technology, and ornamentation, jewelry, art, etc. So we can say this is the metals: ruthenium, rhenium, palladium, silver, rhenium, osmium. So we can say this is the ruthenium, rhenium, palladium, silver, rhenium, osmium, iridium. This is the platinum. This is silver. This is mercury. This is a gold. It's a mercury. So gold, some gold, and some mercury. So So these are noble metals. The commercial value of silver, platinum, and gold. Say those metals which are expensive and have great commercial and economic values are precious metals. Noble metals, particularly silver, platinum, and gold, are considered as a precious metal. तो मेटल्स में जो महंगे होते हैं और इसकी कमर्शियल और इकोनॉमिक वैल्यूज होती है वो क्या होते हैं उसको प्रेशियस मेटल्स कहते हैं. मिसाल के तौर पर जो सिल्वर है, प्लेटिनम है और गोल्ड, ये प्रेशियस कीमती मेटल्स हैं. First come towards silver. Silver is a soft white metal that usually occur in nature in one of the four forms: as a native element, as a primary constituent in silver minerals, as a natural alloy with other metals, as a minor constituent in the ores of the metals. Silver is known as a precious metal because it is rare and has high economic values. It is valuable because it has a number of physical properties that makes it the best possible metal for many different uses. So pure silver is very soft. It is usually mixed with copper to form an alloy for making of commercial articles. यानी जो प्योर सिल्वर है वो सॉफ्ट होता है, इसको अमूमन कॉपर के साथ मिक्स किया जाता है तो फिर एक इलाई बनता है और फिर ये इलाई कमर्शियल आर्टिकल्स को लिखने में इस्तेमाल करते हैं. तो दिस इलाई इज यूज्ड टू मेक कॉइन्स, ज्वेलरी एंड tablewares. Silver chloride combines with silver bromide is used in photography. Silver drawn into sheets and wires. It has a high electrical and thermal conductivity, reflected that way, and reflectivity than any other metal. So platinum. The name platinum comes from the Spanish word platina, meaning little silver. तो ये स्पेनिश जबान का एक लफ्ज़ है जो प्लेटिना में, तो जो प्लेटिना से लिया गया और इसका नाम है लिटिल सिल्वर. तो प्लेटिनम इज the 72 most common element in the earth crust. That's why platinum is an expensive metal. So we can say that platinum is heavy, soft, malleable, ductile, easy to draw into wires, and has fairly high melting point, 1770 degrees Celsius. It is noble metal because it is unreactive. It doesn't even react with oxygens in air. It is resistant to react with acids. तो प्लैटिनम ये एसिड के साथ रिएक्शन नहीं करता, बल्कि ये नोबल मेटल है. नोबल मेटल ये अनरिएक्टिव है, बल्कि ये ऑक्सीजन के साथ भी रिएक्ट नहीं करता एयर में, और ये मोस्ट एसिड के साथ ही रेजिस्टिव होते हैं. प्लैटिनम इज यूज्ड इन a catalyst as a catalytic converter to remove pollutants from car engines, exhaust gases, but is expensive metal, so other metals such as palladium, etc. are used in its place. तो चूँकि ये कॉस्टली है तो लिहाजा इसको हम आम इस्तेमाल इसका नहीं कर सकते, तो उसकी जगह पैलेडियम और पैलेडियम जो है वो यूज़ करते हैं उसकी जगह, प्लैटिनम की जगह. तो the ease with which platinum can be shaped, its strength, color, and inertness makes it suitable for jewelry and gym setting. Another activity also makes it useful in dental filling, making surgical tools, coating, and apparatus for scientific laboratories. We can say apart from that, platinum is also used in the electrical industry, in lasers, and in making photographic materials. So next one is gold. Gold has been used to make commercial. Gold has been made to make ornamental objects and jewelry for thousands of years. Special properties of gold, like a very high luster, attractive color, inertness, tarnish, resistivity, ability to be drawn into wires, hammered into sheets, or cast into shapes, make it perfect for manufacturing of jewelry. Pure gold is too soft to resist the stress applied to many jewelry items. Alloy gold with other metals such as copper, silver, and platinum increases its durability. So you can say that in older days the coins were made of gold. Gold coins were commonly used in transaction upward to paper currency became a more common form of exchange. Gold is used in standard desktop or laptop computers. The rapid and accurate transmission of digital information from one component to another required an efficient and reliable conductor. Gold met this requirement better than any other metal. The importance of high quality and reliable performance justifies orthodontic appliances. Gold is used in dentistry because it is chemical inert, non-allergic and easy for the dentist to work. तो ये गोल्ड के इस्तेमाल के बारे में बताया जाता है कि ये गोल्ड यानी कि कंप्यूटर्स में, डेस्कटॉप कंप्यूटर में इस्तेमाल किया जाता है. Transmission of digital information from one component to another. So गोल्ड डेंटल फिलिंग में भी इस्तेमाल हो जाता है. टूथ क्राउन्स बनाने के लिए इस्तेमाल करते हैं because it is non-allergic and easy for dentists to work. Now, non-metals. So what are non-metals? You can say what are non-metals. So non-metals are those substances which are non-conductor of heat and electricity. They are neither malleable nor ductile. The oxides, hydroxides are acids. Non-metals exist in all three states of matter at room temperature. A non-metal is one which burns in oxygen and produces an oxide which is usually acidic. When dissolved in water, forms an acidic solution that turns blue, litmus paper red. Scientists redefined the non-metal on the basis of laws of gain of electrons. Non-metals is an element which gains an electron and forms lines. So, for example, यानी non-metals क्या चीज़ है वो एक एलिमेंट होता है जो इलेक्ट्रॉन्स को गेन कर लेता है और एनायंस बनाता है. मिसाल के तौर पर क्लोराइड non-metal gains electron to form chlorine. You can say chlorine is non-metal. It's gain electron to form chloride ion. non-metals are electronegative, and so they have the tendency to gain electrons. Chlorine plus gain 2 electrons to produce chloride ions. This is the comparison of metals and non-metals. Non-metals. Metals are electron donor during chemical reaction. They are reducing agents. Non-metals are electron acceptors during chemical reactions. They are oxidizing agents. Metals become positively charged and in solutions, so they become negatively charged and in solution. So you can say that some metals can replace hydrogen from acids to form salts. Non-metals cannot replace hydrogen from acids. We can say metals form basic oxides. So the soluble basic oxides form alkalis when they dissolve in water. Non-metals form mainly acidic oxides which dissolve in water to form acids. Metals form electrovalent ionic chlorides, so non-metals form covalent chlorides. Metals don't combine easily with hydrogens, so few hydrides forms are electrovalent. Non-metals combine easily with hydrogen to form many stable covalent hydrides. Metals usually solids at room temperature, except mercury often. Non-metals are often gases, can say bromine, sulfur, phosphorus, iodine, carbon, boron, and silicon. So you can say, these are solid, but others are gases. So metals are good conductor of heat and electricity, while non-metals are poor conductor of heat and electricity, except graphite. Electronegative character. All non-metallic elements have the ability to gain electrons from other elements and hence are electronegative in nature. So ये बता रहे हैं यानी कि जितने भी नॉन मेटल्स हैं वो सारे इलेक्ट्रॉन्स को गेन करने की सलाहियत रखते हैं दूसरे एलिमेंट से और खुद इलेक्ट्रोनेगेटिव बन जाते हैं तो फिर इलेक्ट्रोनेगेटिविटी इज कैन से मेजर ऑफ a measure of an atom ability to attract the shared pair of electrons of a covalent bond to itself. तो इलेक्ट्रोनेगेटिविटी क्या है वो मेजर ऑफ एटम इन एक एटम की वो खसूसियत हो यानी एक एटम की जो ना इलेक्ट्रॉन खींचने की सलाहियत हो इलेक्ट्रॉन पेयर या इलेक्ट्रॉन को खींचने की सलाहियत को हम कहते हैं इलेक्ट्रोनेगेटिविटी so in short we can say that the elements placed on the right corner of the periodic table will be the most electronegative elements which are non-metals. At the right corner of the periodic table is the group 7 which is the most electronegativity in the non-metals. Halogens, you can say. Group 7 elements are collectively called halogens. Halogens family consists of 5 elements: fluorine, chlorine, bromine, iodine, statine. The word halogen is derived from Greek word means salt forming. Halogens are found in the environment only in the form of ions or compound because of their high reactivity. They don't exist in the element form in nature. Halogens are non-metals, so at room temperature, fluorine and chlorine are gases, bromine is a liquid, iodine and statine are solid. Halogens are very reactive. The reactivity decreases from fluorine to statine. Fluorine is the most electronegative element. Statine is radioactive with short half-lives. Halogens reactivity. The electronic configuration of group 7 is NS2 NP5. They need one electron to complete their rotate. यानी हेलोजेंस ग्रुप 7 में पाई जाते हैं और इसकी इलेक्ट्रॉनिक कन्फिगरेशन है 1s2 2 NS2N P5 और इसको एक इलेक्ट्रॉन चाहिए होता है अपने एक्टिविटी को मुकम्मल करने के लिए और तो फिर ये क्या करते हैं ये बाई गेनिंग इट फ्रॉम लेस्ट ये इलेक्ट्रॉन को गेन कर लेता है जो उस एटम से जो लेस इलेक्ट्रोनेगेटिव होता है सो जब ये इलेक्ट्रॉन को गेन कर लेते हैं तो दे फॉर्म्स एनाइंस कॉमनली नोन एज halide ions. This halogens you can say they gain two electrons to produce halides. So where X is the halide ion, for example, chloride ion is formed as follows: Cl2 plus 2e 2Cl. So this is the chlorine gas, you can say, and this is the bromine liquid. This is the iodine acids. So we can say the chlorine. This is the chlorine and bromine liquid, and this is the iodine. Acid and vapors. Physical properties of halogens. The group of halogens is the only group in periodic table which contains elements in all the three states of matter at certain temperature and pressure. They are poor conductor of heat and electricity. Some of the characteristic properties of halogens are given below. So I can say that characteristic property of halogens, you can say that the halogens, in halogens, fluorine has atomic number 9, chlorine has 17. So this is given the electronic configuration of fluorine is 1s2, 2s2 and 2p5, while that of you can say chlorine is 3s2, 3p5. So you can say physical state of fluorine is a pale yellow, while that of fluorine is greenish gas. So melting point, you can say melting point of fluorine is -219, while of chlorine is -101. Boiling point is -188 of the bromine, fluorine. So that of chlorine is -34. You can say all other features, properties are given, which can be studied. So chemical reactivity of halogens. Halogens are strong electronegative elements. They have the tendency to form negative ions which react strongly with electropositive metals. Halogens are very reactive elements existing in diatomic state. They form single covalent bond between their atoms. They react with hydrogen, oxygen, metals, nonmetals, and other compounds. So reaction with hydrogen. Halogens react with hydrogen to form respective hydrides. Fluorine reacts violently. Chlorine reacts in the presence of sunlight. Bromine reacts on heating. And iodine reacts reversibly with hydrogen. HF differ from other hydrogen halides as it liquid at room temperature due to strong hydrogen bonding. The hydrides act as strong reducing agent. So you can say hydrogen plus fluorine to become HF, hydrogen plus chlorine become HCl. You can say that hydrogen bromine to become hydrogen bromide, hydrogen with iodine to form hydrogen iodide. Reaction with oxygen, so we can say fluorine reacts with oxygen to form fluorine monoxide and dioxide, while other halogens form oxides like dichlorine, hydroxide, etc. So this is the reaction of fluorine with oxygen to produce the product. This is a reaction with metals, so we can say halogens reacts with metals to form the corresponding halides. So it's a copper metals, bromine reacts with copper bromide. This is similarly potassium metal reacts with iodine to form potassium iodide. So reactions with nonmetals. Halogens react with nonmetals forming respective covalent halides. For example, with phosphorus form tri-pentyl halides. The reactivity reaction decreases from fluorine to iodine. So this is the reactions, phosphorus with chlorine. These are given, you can say, phosphorus with bromine. This is the reactions with other compounds. The chlorine with hydrogen sulfide to form HCl and sulfur. With, you can say, ammonia, chlorine reacts with ammonia to form HCl and nitrogen gas. Chlorine reacts with lime water, you can say, to form bleaching powder and water. So displacement reactions, you can say, a more reactive halogens will displace a less reactive halogen from its halide solution. You can say the order of reactivities, fluorine is more reactive than chlorine, and chlorine is more reactive than bromine, and bromine is more than iodine and astatine. So we can say the sodium bromide reacts with chlorine to form sodium chloride and bromine. So this is the end of the chapter, and we'll discuss the key points in next video.